Hello friends, today I will discuss the starting methods for the synchronous motor. Synchronous motor is not a self-starting motor, so it should be started by some methods. There are two widely used methods. One is called starting as a induction motor. The second method is starting as a wound motor. First, let me consider the starting as a induction motor. In a synchronous motor, there is a stator, there is a rotor. So if the rotor is like this, this is a four-pole salient pole synchronous motor. So this is one pole, this is one pole, this is another pole, this is another pole. In the pole faces, there are slots like this. Here, 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 like this. So in these slots, winding is placed. That winding is called the damper winding. So they are just like squirrel cage induction motor conductors. Here also the conductors are placed in the pole shoes of the or pole face of the rotor of the synchronous motor like this. And similarly, there is a winding surrounding the each pole like this, and that winding are connected to the slip rings and brushes, and these brushes will be connected to the DC supply which is placed on the shaft of the motor. So these windings is shown like this. They are called damper windings. This is nothing but rotor core, and this is the excitation winding for the rotor poles, and these are the brushes, these are the slip rings. In this method, initially there is no DC supply connected to the brushes, and three-phase AC supply is given to the stator of the synchronous motor. So these damper windings works like a induction motor rotor conductors. That is, voltage is induced in these conductors, so current also flows through this. So as the stator produces the rotating magnetic field, that magnetic field will rotate at a synchronous speed, and that field will cut these damper windings. As a result, current will flow through this. So the rotor works like a induction motor. So that is, this rotor starts rotating at a speed less than the synchronous speed. So under this condition, the brushes will be connected to the DC supply so that the poles of the rotor will be excited. As a result, this rotor will lock up or will synchronize with the stator magnetic poles, that is 4 poles. So when the rotor wound for 4 poles means the stator poles also will be 4 poles only. So it can be observed that with the damper windings, this synchronous motor starts as a 3-phase induction motor, but with the DC supply connection to the rotor field winding makes it to work like a synchronous motor. That is, the rotor will lock with the stator rotating field to run as a synchronous motor. What are the advantages with this synchronous motor when it starts as a induction motor? That is, it will have the low starting torque but high starting current. And coming to the application, wherever there is a low starting torque requirement with less load, this type of motor is used. Let me summarize once the starting of the synchronous motor as induction motor. In this synchronous motor, there is a stator which will be connected to the three-phase AC supply that will produce the rotating magnetic field whose speed is synchronous speed, and there is a rotor, and that rotor is normally salient pole rotor. So the number of poles in this case considered are 4-pole rotor. So that means stator poles also will be connected for, stator winding will also connected for 4 poles, and the rotor will have the slots to provide the conductors. They are called the damper winding or damper conductors. So this damper winding works like a squirrel cage rotor when three-phase supply is given to the stator of this motor. Then this motor starts as a three-phase induction motor whose speed is less than the synchronous speed. Under these conditions, a DC supply is connected to the rotor for poles, that is to excite them. So then the rotor will lock with the rotating stator magnetic field so that it works like a synchronous motor. And the disadvantage with this is low starting torque but high starting current, and the application is wherever there is a low starting torque required with a less load, this will be used.